If you don't, we gave it out at some point. I think I still have that on my phone, and I could probably still pull that up if you need me to. Yeah, where I offered everyone their hack information. Okay, well, if you took a picture of it, which is what I suggested you do, you have it. Look at that problem solving. Today we're going to talk about ratios. Today we're going to start talking at first about ratios. Anybody ever heard of a ratio before? Okay, so who can give me a quick, I think I know what a ratio is, definition for what a ratio is? Bennett?
We have 1, 2, 3, 4, 5, 6 of all the numbers. The highest number of the factor that's the lowest number is the ratio, I think.
Okay. Anybody have another guess? Leilani?
That's like kind of for each like unit or thing that you have, there's another thing comparing against it.
Okay, that's a pretty good definition. Tara, what'd you get?
Like with the circle, you have the circumference.
That's circumference, diameter. A ratio is a comparison of two things, two numbers, or measurements using division. It's a comparison of two things. I'll give you an example. There is, in this classroom, a ratio of boys to girls. Okay? And in order to find out what that ratio is, all I would need to do is count how many boys there are, count how many girls there are, and set that ratio up. Now, ratios, if you can look on the board, a ratio can actually be written three different ways. Now, I do not want it written like this. I would prefer it to be written like this. You can either write it with a colon in between. By the way, you would say this as the ratio of 3 to 5. That's how you would say that ratio, 3 to 5. You would say this as a ratio of 3 to 5, and obviously this is a little bit easier to say that way. 95% of the time, you are going to write a ratio as a fraction. You were going to write a ratio as a fractional, Dave?
So basically, a ratio is for every 5 girls is 3 boys.
Something like that. Yeah. Now, let me ask you a question. Do you think the order would matter?
Yes.
It absolutely would. If I said that the ratio of girls to boys is 3 to 5, then which one is girls and which one is boys, Bennett? No, I need an answer. And by the way, I'm recording it, so that way, your parents can hear how people contribute. Okay. So, give your answer. What's your answer? Bennett, raise your hand for the answer. What's the answer? Why would it matter? Why does order matter? If I say the ratio of boys to girls is 3 to 5, which one's which? Answer. Okay, Nolan. No, and I should have written it down. If I say the ratio of girls to boys, then is 3 to 5. The order absolutely matters. The order absolutely matters. And it's important that you set it up in the order in which I ask for it. Because if you tell me the answer is 5 to 3, it's a wrong ratio. So order absolutely matters. And what a lot of kids will do is when they're writing it, they will write what it represents next to the number just to kind of keep it straight in their heads. Ratios are often expressed as fractions. 90 to 95% of the time, you'll express a ratio as a fraction. Is this fraction the same as this fraction?
Yes.
Good. If I said the ratio of dogs to cats is 5 to 20, is this the same ratio?
Yes.
It is. It actually is. Because for every one dog, I end up with 4 cats. So then if I have 2 dogs, how many cats do I have? 8. And 3 dogs? 12. And 4 dogs? 16. And 5? 20. So it works a lot like equivalent fractions.
For each 5 dogs you have, you have 20 cats.
Yeah, for every 5 dogs you have 20 cats. Which means that for every 1 dog you have 4 cats.
That's a lot of cats.
That's a lot of cats.
That was the worst.
Alex.
In like scale models, like if you're trying to build a small model, something ginormous, you'll have like
Exactly, yeah. If anybody's ever done a model, they will tell you that the scale is like 1 to 24. They're giving you the ratio.
Whoa, but like a math, like something that
What?
like for like a math, 1 mile to.
Or like a math, 1 mile, what? 1 inch equals 3 miles or something like that. Well, you look at the math sheet. Yeah. I'll tell you some other places they use ratios.
Well, 1 mile.
The gas station.
Oh yeah. Yes. Yeah.
When you buy gas,
Oh yeah.
it costs a certain amount of money per 1 gallon. That's a ratio.
Like
Christopher?
Isn't understand like if you go to like certain candy stores, like they'll have like a price per pound?
Yeah, mom and popcorn. If you ever go to mom and popcorn, they sell their bulk candy by the ounce or by the pound or something like that. Tara?
Is this still 6th grade math?
Sort of. This is actually 6th, and this will be 6th and 7th, and in this unit we're actually going to do 6th, 7th, and 8th. All three. Yeah. It was unit 2, integers, types of numbers, things like that. 6th and 7th.
Yes, we get to outsmart.
Okay? So, a ratio is the comparison of two numbers within the same units by division. A ratio can be written in one of 3 different ways, right? So, I could ask you, what is the ratio of green rectangles to blue rectangles? I could ask you the ratio of blue rectangles to green rectangles. The important thing, let's do blue to green. If I said, what is the ratio of blue to green rectangles in this picture? Alex?
I would say 1 to 3.
Okay, but before you did that, I want to know the unsimplified version first.
Oh, 8
8
to 12.
to 12. So we would just count the blue, and then we'd count the green. 2, 4, 6, 8, 10, 12. Now, 8 to 12 is a correct ratio. However, just like with fractions, that is not a good final answer for me. I want it as a simplified version. Both are divisible by 4. So you end up with a ratio of 2 to 3. Okay. By the way, could I have also asked you the ratio of blue rectangles to total? Sure. Green rectangles to total. Total to blue.
Yes.
Sure I can. Because you can write, there are 20 total. If I'm doing total to blue, it would be 20 over 8, which simplifies to what?
2 and 4, 20 and 5, 2 and 1, 5 over 2. 5 over 2.
Does this simplify?
Yeah.
No, it doesn't.
Oh, we're not doing.
Because a ratio must always be in the form of one number in comparison to another. If you change it to a mixed number, it is no longer a ratio. You will never simplify a ratio into a mixed number. You'll always leave it as what's called a simplified improper fraction. Yes, ma'am.
So you would say like 2, 3, and like not 2 over 3?
You would say 2 to 3. You would use the TO word in between. This is the ratio of 5 to 2.
Like 5.
No, 5 to 2. They're 2, and that's an important thing. Leilani said you wouldn't say this is 5 over 2. You wouldn't. Because remember, the 5 represents something and the 2 represents something. It's a comparison of one thing to another. Total rectangles to blue rectangles. Yes?
So we've kind of been doing this since like 5th grade, but we just haven't been saying it that way.
That's exactly right. That's exactly right. And again, you don't want to simplify it to mixed numbers. So what I would like for you to do is I want you to come up with your table with as many ratios as you can. When you write them, I want you to make sure that each of your numbers, you know what it represents. So if that means you have to spell out the word. That means you're going to use initials. You can use initials, but come up with as many different ratios as you can in those figures. Okay, so let's see what we got. Let's see how many different ones we could come up with. Let me make this smaller. unlock. Okay. So let's see what we came up with. Let's see. Sasha, what did you come up with? Give me one of the ratios you came up with. Say again. 5 to 3. 5 to 3 what? What does the 5 represent? What does the 3 represent? Okay, so you said 5 was the small and 3 was the large. Were you counting? So 1, 2, 3, 4, 5. 5 small, 3 large. Perfect. Let's see. Nilla.
Yellow to red butterflies.
So you did yellow to red, and what'd you get as a ratio?
3 to 4.
3 to 4. Perfect. 3 to 4. Very good. Christopher.
We got 5 to 7, 5 feet that you can see, and then 7 without feet.
5 with feet that you can see, and 7 with, I like that. 7 with no feet. That'll work. And you can't simplify. Gavin.
Red to orange.
Red to orange, and what'd you get?
4 over 5.
4 over 5. And in each case, there's no simplification necessary. Hatai and then Tara.
Okay, so yellow and the multicolored butterflies over total.
Yellow and, wait, say it one more. Yellow and,
Multicolored butterflies.
so on the top you had yellow plus multicolored over total. So what were your numbers?
8 over 12.
8 over 12. Did you simplify that?
Yes, it's 2/3.
Very good, because we would then simplify to 2 to 3. Very good. And remember, when we say a ratio, be cautious about saying it as a fraction. Say it as a ratio, 2 to 3. Tara.
Red plus multi over total.
Red plus multi over total, and what'd you get? 9. Very good, which then simplifies to 3 to 4. Very good. Yes, ma'am.
Large to total.
Bless you. Okay. 3 over 12, and then we simplify. Very good. Remember, 1 to 4. Remember, watch your language, watch the vocabulary when you talk about ratios. And by the way, you can go on and on and on, because here's an interesting thing. For every one of these, you can do its inverse. So instead of red to orange, you can do orange to red. The number of different, what we call derivations of ratios can be pretty significant, because I love the fact that Tara and Natai started like going, well, yellow and multicolored to total. When you start thinking of all those different possibilities, it becomes pretty significant. Do you basically understand how a ratio works? Okay? So like in this room, I could do boys to girls, girls to boys, boys to total students, girls to total students, students to boys, students to girls. Then we get the hair. Yeah, well, we're getting the feet. Who wore socks, who didn't? Okay, now, a couple of quick things, then we're going to get into classwork. I always want your ratio, written in simplest form. Now, before you do that, I want to see the unsimplified version before I see the simplified version. And the reason is that way if your simplified version is wrong, I know what happened. And it doesn't take any extra time to write the unsimplified, then write the simplified version. But I want to see both. That way it's not that you miscounted, it may be just that you did the math wrong. Okay? Any questions on that? Okay, one other type of rate that we're going to talk about, that's just, again, simplest rate. Write the ratio of 60 cents per dozen. Be careful about words like dozen, because dozen represents a number. What's the number? 12. So when you write the ratio, you want to write it with the numbers properly. By the way, I would have actually said this is not correct. I would have wanted that. I generally want dollars, not cents. I want it written in dollar form, of course. I want it written in dollar form, not cents form. And by the way, money is always in the top of a ratio. Always. Think about anybody ever been to the deli counter at the grocery store? What will the price tag say? It is a ratio. $5.99 per pound,
Yeah.
$9.99 per pound. That's a ratio.
So it'd be $9.99.
Yeah, it is in fact a ratio where they're selling whatever meat that might be as $9.99 for every pound.
Oh, yeah.
Okay? But the money is always written on the top. Yes, ma'am.
Okay, so two things. One, if it said over like pound, would we have to find out how much ounces or something is in it?
No, generally you can leave it in pounds.
And two, would a decimal like number affect us other than money?
Yeah, every once in a while you'll end up with, I'll give you a quick, in fact, we're going to get to that in just a second in unit rate, which is the next thing. We're going to talk about unit rates. A unit rate is a ratio where the bottom number is 1. A unit rate is a ratio where it's simplified all the way down to where the bottom number is 1. All the time, okay? And the reason that becomes important, if they say, hey, you can buy 3 gallons of milk for $10. Well, most people, the first thing they want to know is, well, how much is it for each one? That's called the unit rate. The unit rate is per 1.
Because then they know if they're getting ripped off.
Yeah, then you know if you're getting ripped off or not. Because sometimes it looks like something's on sale.
But it's just
What does it say? Hey, it's normally $5 each, but special for you today, you can get 2 for $10. You go,
There's no difference.
yeah,
2 for $9.
that happens more than you think.
2 for 11.
Yeah. Yeah, right? Yeah, exactly. It's only $5 a piece, but today it's 2 for 20. You're so lucky.
No, it will be like $5 each day, and then on that day.
Yeah.
I like that
Voice.
how
If you want to go buy something like food and it says 99 at the end, you think you're getting a deal,
Yeah.
but then it's actually just round.
A lot of people ask, so why do they sell homes for like $299,000? Why don't they just say $300,000? Well, because when you're spending the money, it just feels better to know you're spending $299 versus $300.
even though it's really good.
Even though it really doesn't. At that point, what does it really matter?
Tax.
You know?
It's just a tax
Yeah.
to make it.
So let's talk about the way that unit rate works. Read this. The cost of a 12-ounce box of Cheerios is $3.29. The cost of a 12-ounce box of Cheerios, Publix brand Cheerios, cost $4.89 for an 18-ounce box. So the question becomes, how would we find out which one is the better deal? Well, here's what you do. I always said money goes where? Money goes on top. So we set up our first ratio, which is $3.29 over 12. And you would actually set that up as a division problem. You would do $3.29 divided by 12. There's no outside decimal. Decimal comes up. That's 0. 2 is 24. You subtract, you get 89. That's 7, which is 84. You subtract, you get 5. You add another 0.
That's
4.
4.
Now, do I need to keep going? Why?
With money, it doesn't go up.
With money, you only stop 2 digits after the decimal. Now, I went to the third so I'd know whether to round up or stay the same. In this case, it's... Now, here's what this means.
No, it's not.
Oh, my bad. Very good. Here's my point. For this brand of Cheerios, it costs 27 cents per ounce. That's the unit rate. It's 27 cents per 1 ounce.
So you have to do a lot of math, don't you? Because
Yes.
then you've got to multiply that number to see if the other.
Well, no. Wait, I'll show you. Leilani.
Aren't like when you're dealing with money, you always round up?
No, you do not. You only round up if you need to round up. Gentlemen, I'm asking out 3 times. Okay. Now, I come over to the next one. I have $4.89 for 18 ounces. I do the exact same thing. I divide. And I end up with this. So this is one. This is the first one. This is the second one. Which one is the better deal? Get it? This is a better deal because it's cheaper per ounce.
But really, you're paying the same amount.
You're paying the same amount unless you were buying like massive quantities. Say you're buying like 18 pounds of Cheerios a week. Then it might matter, right? Bennett?
So we should like divide that 8, take that 8, and then add it back to the price on your tax.
No. Because the tax is the same no matter what.
Oh, it wouldn't matter because
The tax rate, which we'll get into later on in this unit, doesn't affect this.
It's multiplied by the state, so Texas is like 8 is like 8 is
If you find out that the one on the left is 0.274 per every 1 ounce, and the one on the right is 0.271 for every 1 ounce, you now know which one's cheaper. Therefore, you know which one's the better deal. But are they the same?
They're both 27 cents.
Okay, Brendan, then you answer none of the above, and I'll use my red pen to put a big X on it. Because the right answer is that one is not, these are not the same numbers. They're very, very, very close, but they are not the same
And
numbers.
Mr. Bennett, you're buying, say you buy 10 ounces, then you got, then there's not a point.
Or 100 ounces, or
There's
1,000.
not a .271, it's just point, it's just 2 digits.
Well, I will tell you, if you go to the grocery store,
So that's why the other was better.
just listen, if you go to the grocery store and look at the little stickers on the shelves, they will give you the unit rate per ounce, per pound, per whatever. And if you do that, you'll notice that they generally go to the thousandths place. They generally go to the thousandths place. Labib?
No, because like that was cheaper because like if you buy more and more, it will matter sooner or later.
Yeah. Now, I want to talk to you really quickly so you make sure you understand how I want the ratio set up. A lot of times they give you these acronyms. MPG is one. MPG stands for miles per gallon. It's used when we determine gas mileage for cars. If you go to the state fair, you go to a car dealership, they have a little sticker that says, this car gets 24 MPG, miles per gallon. When they give you that, they're giving you a ratio. Make certain you would write it in the right order. 24 miles per gallon is 24 miles over 1 gallon. Tara?
What would happen if you did one gallon every 24 hours?
It would be wrong. It would be wrong. You have to pay attention to their words, especially when they ask you a question. They'll give you the order in which they want it. Alex?
If MPG stands for miles per gallon, then does RPG stand for rockets per gallon?
RPM. It's RPM. RPG is a rocket-propelled grenade. RPM is revolutions per minute. Yeah.
That'd be used for like a jet engine.
Okay, so here's what you got. You're going to have classwork and homework. The classwork is a short sheet